In this session, I want to start thinking a little bit about types of values. So I'm going to come back to this bank account class that I'd created previously. And ultimately, the computer only understands the difference between two values, okay? What we call bits or binary values. And so one of our fundamental or primitive native types of data that we have available is an individual bit that has one of two values that we can think of as yes or no, true or false, on or off kind of thing. And we refer to those as Booleans. So in UML, we specify types with a colon after the name. So let me back up here and think about, well, with this bank account, is there some property or characteristic of a bank account that would be yes or no? And I'm thinking, well, maybe the bank account is active. So I'm going to come up here and say, oh, there's another property of this bank account, and the name of the property is active. Okay. And then I'm going to say colon, Boolean, to say that the value of active, think of active as a variable, if you will. The value for that name can either be one of two things, yes or no, true or false. And again, I think it's either active or inactive. The balance is a little more straightforward. We're used to that. And I'm going to say, oh, that's a number. Now, there are subtypes of numbers. We can worry about whether it's a whole number, whether it has a fractional part, and we'll talk about floating point numbers and things. But for the moment, at this level, we don't need to worry about those details. We can just say that, okay, it's a number. And numbers are, again, one of our basic fundamental types. The CPU in our computer can actually manipulate groups of bits as numeric values. When we look at the the owner property, what we find is it's not a number and it's not a Boolean. This is somebody's name. It's a series of letters or a string of letters, characters kind of thing. So I'm going to refer to this as a string. Okay, and that's the common term that we use in a lot of computing languages when we think of strings of characters, strings of letters. And so again, there is a subtype there of individual characters, but we're not going to worry about that. So three basic fundamental primitive types that we almost always have are strings, numbers, and Booleans. Okay. And in a weakly typed language, we rely upon the translation from our natural language into the machine's language to try to figure that out. And a lot of times it can. And then we have other languages that we refer to as being strongly typed, where we have to tell the translator what the types are. Okay. Methods then, the question is, do methods have a type? And, well, we could say certainly that the parameters do. Okay, so like amount, we could put in here and say, oh, that's a number. Let me drag this out a little bit bigger here. So each parameter can have its type, but does the method itself have a type? And the answer is yes, it can have. And that is the type of value that it's going to return when it's done. So if parameters are ways of passing data into this method, then the method, when it's done down here, has an opportunity to return a value back to whatever called it. Okay, so whatever told it to withdraw some amount, it can return a value back. And so the type for a method is the type of the return value that has the type of value that it's going to return. And I'm going to suggest that our withdraw method, deposit2 probably, is going to return a Boolean, because the result of the withdrawal is either going to be success or failure. Either there was enough money there and you own the account and you took it out, or it wasn't your account, you didn't have enough money, whatever, and there's success or failure there. So over here in my diagram then, I'm going to change this. So remember, we came down and we said, okay, is this the owner? Okay, is the object calling this method saying, hey, withdraw this amount, is it that object the owner of this bank account? And if it is, we're going to go on. But if it isn't, okay, we sit over here, we say, okay, this is the no branch. If it isn't, then we should return false. Okay, so I'm going to say, I'm actually going to change this one because this is a no path as well. And I'm going to change this to return false. Okay, and say now that this path is going to join here. It's my OCD kicking in, but I'm going to leave it for the moment and say that, okay, if they're not the owner or the balance is not greater than the amount, then we're going to return false, indicating that it was unsuccessful. And so then over here, if they are the owner and the balance is greater than the amount, then we're going to subtract the amount from the balance. And at this point, we can return true here. A couple little details there. One is I don't have to have a box for each individual statement. I can put multiple statements in a box like I did here. I've got two. One is changing the balance, and the other one is what value to return. The other thing is if I'm saying return here, then the actual end symbol becomes a little bit unnecessary. When you return, that's it. There's no way that anything could continue from here. So it becomes a little bit redundant, and I could just stop there. There are times when we don't return something, or we have a special type that we call void, meaning nothing, a value of nothing, a type of nothing, and we could return that. But a lot of times, if we just don't say that we're returning anything, then we would end silently and not return a value. Okay. Again, the parameter up here, that could have a type as well. If I was cleaning this up a little bit, and I would say, okay, the amount is a number on that. So yeah, that gives us an introduction to this idea of types, and every piece of data has a type associated with it. In fact, what's happening is as we're making these classes, we are specifying new types. So it's kind of like Legos. Strings, numbers, booleans are the smallest little shapes that you have to work with, okay? And then we can combine those together, make what we would call a composite type from those, and then we can use that as part of another bigger type, and use that as part of a bigger type. So, for example, I could come over here and say, well, okay, now that I've made this bank account type, that could be part of a portfolio class. And so one of the things in the portfolio would be an account of the type bank account. Get rid of a little bit of that other stuff there. And I'll think about operations that a portfolio might have later. But again, you can see that I am using this type that I've made, bank account, that is a composite of a string, a number, and a boolean. And I'm using that as a type of one of the properties in a portfolio.